This is the second video in the series on aldehydes and ketones. In the last one we learned about naming ketones. In this one we're going to learn about naming aldehydes. You may say, well, they should be the same system because aldehydes and ketones are basically the same thing as each other. Unfortunately, no, it's a completely different system. So, first of all, what are aldehydes? Well, they are molecules that have the C-double bond O, in other words, a carbonyl group, just like ketones do, with one or possibly two hydrogens bonded to the carbonyl carbon. So this one has a C-double bond O with two hydrogens. This has a C-double bond O with one hydrogen and a carbon group. This one has two C-double bond O's, both with hydrogens and carbon groups. So this one's a dialdehyde. This is another example. This is just written in a little bit more condensed form, where the hydrogen on the carbonyl carbon is shown in line, and then the double bond O is shown. This is another example, and you have to get used to the fact that CHO is a very shorthanded notation for an aldehyde group. In other words, this right here is a CHO group. The problem with this is it doesn't show that there's a double bond O there, but you'll recognize it pretty quickly that CHO means there's a double bond O there. Here's another one with a C double bond O showing, but this could be written as CHO. Here's another CHO, so that's an aldehyde group. It's a carbon with a double bond O and a hydrogen, and then another carbon group. And this one down here happens to have a carbon-carbon double bond in it as well. This one happens to have a ketone in it as well, so this one's both an aldehyde and a ketone. And this one has an aldehyde group, but also has OH groups in it, so it's an alcohol. In fact, a diol plus an aldehyde. Okay, so let's start with naming aldehydes by the common system. Unfortunately, like it or not, there's a whole new set of prefixes that we have to learn. So up till now, you're used to meth, eth, prop, bute, pent, hex, hept, and so on for numbers of carbons. Well, with aldehydes, and for that matter with carboxylic acids, actually it started with carboxylic acids. As I've said, the common names of aldehydes are analogous to the common names of carboxylic acids. They have a new set of prefixes. A one-carbon aldehyde is called formaldehyde. You've probably heard of formaldehyde before. It's a common preservative, obviously, and its common name is formaldehyde. It's related to a carboxylic acid called formic acid, which is one-carbon carboxylic acid. This one with two carbons, in other words, a C with one hydrogen and a methyl group on the double bond O, is called acetaldehyde, or most people just pronounce it acitaldehyde, which kind of sounds like the word acitaldehyde, but it has nothing to do with that. This is acete, A-C-E-T, and it's related to acetic acid, which is the corresponding carboxylic acid to this one. But you just have to remember that this particular compound is called acetaldehyde. Propionaldehyde is a three-carbon aldehyde. Notice that the aldehyde group is always at the end of these chains, as an aldehyde group has to be, if you think logically about it. If there's a C-double bond O and a hydrogen on that carbon, that has to be then at the end of a chain. You cannot have an aldehyde in the middle of a chain. But anyway, notice that propionaldehyde has three carbons, including the aldehyde carbon. So prop, we've kind of come to learn that prop means three, but it's not propanaldehyde, it's propionaldehyde. Got to get the spelling right. And then similar thing here, bute. Oh, I'm sorry, that should be B-U-T-Y-R-A-L-D aldehyde. So butyraldehyde is four carbons. Again, bute typically means four, but this is not butanaldehyde, it's butyraldehyde with a Y-R in there. It's just a weird way to spell it, but that's the common system for four-carbon aldehyde. Five-carbon aldehyde doesn't have anything to do with pent, it's just balar, B-A-L-E-R. Balaraldehyde is five carbons. Caproaldehyde, six carbons. By the way, capro comes from goats, and you're probably familiar with Capricorn. Capricorn means the goat. So caproaldehyde is named after the same root word as caproic acid, which comes from goats. And if you smell caproic acid, you'll know it smells pretty much like goats. Pretty weird. But this is caproaldehyde, which is a six-carbon aldehyde. There are other common names for bigger aldehydes, but we're just going to learn these six. And then another one that's very important, which is used all the time, is benzaldehyde. In fact, benzaldehyde is so commonly used for this particular compound. That's actually not only the common name, it's also actually the IUPAC name for that compound. The IUPAC people, when they were first coming up with the system, said, you know what, we'll give up. Let's just call it benzaldehyde because we know that's what everybody's going to call it anyway, so we just called it benzaldehyde. Okay, then, in the common system, we have to have ways of indicating where various groups are attached on a chain. And so what we do is we use the Greek letters alpha, beta, gamma, delta, epsilon, and so on. And by the way, this Greek letter is omega, so if you have something that's attached on the last carbon of a chain, sometimes people refer to the omega carbon, just meaning in general it's the last carbon on a chain. So this particular one would be both the epsilon, which is the alpha, beta, gamma, delta, epsilon carbon, but it would also be called the omega carbon because it's the last carbon in the chain. Anyway, notice that when we're using Greek letters, we don't start at the carbonyl carbon as alpha, we start at the one next to it as alpha. And we have seen in the past, if you remember, cases where a carbon next to a functional group is called the alpha carbon, and a carbon one removed from that is called the beta carbon. Well, it's based on the same system as we have here. So anyway, the next door is the alpha one. I'll give you a preview in the IUPAC system. That's called carbon number 1. But in the common system, that's called carbon number alpha. Okay. So here's an example. If we have a chlorine on a 3-carbon aldehyde, the 3-carbon aldehyde is called propene aldehyde. It would have a chlorine on the alpha carbon, so it's called alpha chloropropene aldehyde. And this one, just another example, has 3 OH groups, one on the alpha carbon, one on the beta carbon, one on the gamma carbon of butylaldehyde. So alpha, beta, gamma, trihydroxybutyraldehyde, which, by the way, is a fairly common biochemical that's found in cells and cellular processes. Okay, so common system for aldehydes, unfortunately, a little bit more work for you. A couple of new things there. IUPAC system for aldehydes, not too bad. Again, the only new thing is that you change the E of an alkane name into AL. So AL is for aldehydes, ONE is for ketones, OL is for alcohols. And we have to be careful when we pronounce them that you pronounce al and not all, because if somebody hears you say all, they're going to think you're talking about an alcohol. Well, al is the ending for aldehydes. Okay, so notice we find the longest chain, and it's always going to start with the aldehyde carbon. So if there's a longer chain that doesn't start with the aldehyde carbon, you don't use that chain. You use the chain that starts with the aldehyde carbon, and then you find the longest chain from there. In this case, it's easy. It's 1, 2, 3, 4. So it would be based on butane, but we take off the E and we put on AL, and it becomes butanal. In this case, 1, 2, 3, bromine at carbon number 3. And notice you always start at the aldehyde as number 1, because it always has to be at the end of a chain. So this would be 3-bromo-butanal. It's not pronounced anal, it's pronounced butanal. This one, a little bit more complicated. Notice it has 1, 2, 3, 4, 5, 6 carbons, and so it's hexanal, except it's also got an alkene double bond in it, so it's hexene-al. And since the ene comes at the 3rd carbon, 1, 2, 3, it's 3-hexene-al. And in this particular case, it's also got a methyl group at carbon number 4, 1, 2, 3, 4, so it's 4-methyl, 3-hexene-al. And then one other little detail here, just for fun. This particular double bond is one that can be cis or trans, and since the higher priority group is this group on one end and the ethyl group on the other end, and they are across from each other, it's an E, 4-methyl 3-hexene-al. One thing I should mention here is that notice we don't put a 1 in the name to indicate where the aldehyde carbon is, because by definition it's at carbon number 1, so you don't have to put in a 1 to indicate where the aldehyde carbon is. Essentially nothing takes precedence over aldehydes, except possibly carboxylic acids, but in terms of the groups that we've learned so far, aldehydes are the highest priority, and then ketones, and then alcohols, and then alkenes and alkynes, and then other things like methyl groups and bromines and stuff like that. Okay, so let's take a look at this one now. How many carbons in the aldehyde altogether, including the aldehyde carbon? Notice in each of these cases we're counting the aldehyde carbon as a member of the chain, so it's 1, 2, 3, 4, 5, so pentanal, except it's got 2 double bonds, so pentadiene-al, and since the double bonds are at carbon number 2, 3, and 4, so 2, 4, pentadiene-al. And then in this case we also have a cyclopentyl group at carbon number 2, so it's 2-cyclopentyl, 2, 4, pentadiene-al. And then this one also, this particular double bond could be cis or trans. This one happens to be trans, or E, because this group is a higher priority than cyclopentane. So you might say, well, why is this higher priority than that? Clearly that's a bigger group. Well, because this has an oxygen in it, and oxygen is heavier than carbon, so this is a higher priority group on this end. This is a higher priority group on that end, so again they're across from each other, so that's E, 2-cyclopentyl, 2, 4, pentadiene-al. And notice that this double bond cannot be either cis or trans, it just is what it is, so we don't have to indicate what its stereochemistry is, and we don't have to indicate which of the two double bonds is the E one, because by definition this is the only one that could be, and so the E refers to that double bond. You don't have to indicate it in the name. And then this one is actually pretty simple. It's got an aldehyde group on one end and an aldehyde group on the other end of a chain, and so it's a di-al. This is a 3-carbon chain altogether, including the carbonyl carbons, so propane di-al. And as I mentioned a few minutes ago, since aldehydes take precedence over ketones, if they are both in the same molecule, then you use the al ending, and you indicate where the ketone is not by an O and E ending, but by an oxo prefix. So oxo is kind of like hydroxy in that you can indicate where it is attached in the chain by putting that as part of the name. So this particular molecule has 4 carbons altogether. 1, 2, 3, 4. The aldehyde carbon's automatically number 1. That's carbon number 2, so that's carbon number 3, and we have a ketone at that position, but we don't indicate on the end, we indicate oxo at carbon number 3, so 3-oxo-butanal. Same idea here. This is carbon number 1 because that's the aldehyde carbon. 2, 3, 4. It's got a hydroxy group at carbon number 4, so it's 4-hydroxyhexanal. We don't indicate an OL on the end, we indicate that it's an alcohol by putting a hydroxy group in front. And this one has an alkene and an alcohol and 2 aldehyde groups. So it's 1, 2, 3, 4, 5, which would be pentane. But because it's got the double bond, it's pentene. And because it's got 2 aldehydes, it's pentene dial. So then the next question is, which end do we number from? Since there's an aldehyde on this end and an aldehyde on this end, well, we would number from this end if the OH takes precedence. We would number from this end if the alkene takes precedence. And we know that OHs take precedence over alkenes. So we number from this end. So it's 1, 2, with hydroxy at carbon number 2, so 2-hydroxy. The alkene starts at carbon number 3, so 3-pentene. And then di-al indicates the 2 aldehyde groups. And then one last thing, as I mentioned before, benzaldehyde is the acceptable IUPAC name for a benzene ring with an aldehyde group. So this is just called benzaldehyde. This is just another way of writing benzaldehyde, and this is yet another way of writing benzaldehyde. Okay, so let's try these examples. So I'd like you to try to write out the IUPAC name, and for that matter, the common name for these 2 compounds. So I'm going to have you pause the video at this point and write your answers in there. Okay, so this one, the longest chain that includes the C double bond O is 1, 2, 3, 4, 5. So it's pentanal, and that's carbon number 1, 2, 3. There's a methyl group at carbon number 3, so it's 3-methylpentanal. That's the IUPAC name. But what about the common name? Well, remember, a 5-carbon aldehyde, 1, 2, 3, 4, 5, is called balloraldehyde. That's just a name you have to memorize. Nothing for it but to memorize it. So balloraldehyde, 5-carbon chain. And remember, it's not the carbonyl carbon, but the one next to it is called alpha, and then the one next to that is called beta. So this methyl group is a beta carbon, so it's a beta-methyl balloraldehyde. Okay, let's switch to this one. This is a little weird because notice that the longest chain is actually 1, 2, 3, 4, 5, 6, 7. But the longest chain that includes the aldehyde carbon, in other words, it starts at the aldehyde carbon is this one. 1, 2, 3, 4, 5, 6. So it's actually 6 carbons are hexanal. So that's carbon number 1. Carbon number 2, we have an ethyl group attached, so 2-ethyl. 3, 4, we have a hydroxy group attached, so 4-hydroxy. Again, even though it's an alcohol, we don't use the OL ending. And so it's just 2-ethyl, 4-hydroxyhexanal. Again, it's the 6 carbons, 1, 2, 3, 4, 5, 6 that we use, caproaldehyde, and it's got a ethyl group at the alpha carbon. This is the carbonyl carbon. The one next to it is called the alpha carbon. So it's alpha ethyl, so that's alpha, beta, gamma hydroxy group at the gamma carbon. So alpha ethyl, gamma hydroxy, caproaldehyde. Okay, so now you can try these 2, and these are complicated enough that they won't have common names. You'll just give them IUPAC names. So try that. The longest chain, 1, 2, 3, 4. So butane. But because it's got an alkene in it, it's butene. We're going to number from this end, 1, 2, so the ene starts at carbon number 2, so it's 2-butene. But because it's an aldehyde, it should be 2-butanal. And it's got 2 methyl groups, one at carbon number 2 and one at carbon number 3, so it's 2,3-dimethyl, 2-butanal. And notice that this double bond cannot have cis-trans isomers because it has two methyl groups that are the same as each other in this end, so there's no E or Z in this particular case. Okay, then let's look at this one. Here's the aldehyde carbon. Notice that this is a ketone carbon and this is another ketone carbon. So two oxo groups, and those are at carbons number 2, 3, 4, 5. So 3, 5, dioxo, hexanal. And that's the end of the lecture for today. Thank you.